Here I'm going to show you how to use the non-Newtonian Casson model in ANSYS Fluent. If you go to SimCafe and go to the Fluent Learning modules and the 3D bifurcating artery, steady actually, the steady module, and go to exercises, you will see a section on the Casson model, and it gives you the definition of how mu is calculated in the Casson model. And mu is a function of the strain rate, gamma dot, which in turn is a function of the velocity gradient. So it's a non-linear model. You need to do this, implement this using a user-defined function in Fluent, and that user-defined function is provided over in the section. So you can download it here. And if I bring it up in Notepad, you will see that that file has two functions. The first one is for specifying a time-dependent velocity profile at the inlet. We'll ignore that. And then there is the one for the Casson model. It's this defined property. And Casson viscosity is the name of the user-defined function given by us. And you can see that it gets the strain rate, magnitude, gamma dot, and then it does the necessary calculations. So to calculate mu using this rather than a constant value, what you have to do is go to ANSYS. So I'll do this in Amazon AppStream or Apps on Demand for the benefit of Cornell students, but you can do this on any ANSYS installation that has a necessary license. So I will say File, Open. I'll load in the WBPZ. And if I go to this PC on Apps on Demand, I can work on OneDrive, which is my network drive. I've noticed that it's a little bit slow, so I'll live dangerously and work off the temporary files. I need to save everything at the end and copy it out. Otherwise, when I log out of Apps on Demand, I'll lose it. And I will open my WBPZ, and it's asking me to save in the conventional format. So I'll save it, I'll overwrite it, and once it comes up, I have a tube flow problem on which I will demonstrate this. And what I will do is, before that, if I go here, go to a temporary file, so I have my WBPZ and then this WBPJ and the associated folder. Right now it's saving it over here, and at the end I'll save it back into a WBPZ. So let me get out of that. I'll duplicate from results. So I'll say duplicate, and you can give it an appropriate name. I won't do that in the interest of time. And you can see the geometry is just a reference and the mesh is just a reference. I need to modify things in the setup, and I'd like to start Fluent from solution as much as possible because it loads up everything. And after you twiddle your thumbs, Fluent will come up, and sometimes I have to go here and say default if things get garbled, and let me go away from the maximum view. Notice that for Apps on Demand use, I've turned off my bookmarks toolbar to maximize the screen real estate. So I have to first interpret the user-defined function. So I'll go to user-defined functions, interpreted, browse. If I go up a few levels, okay, that downloaded file, I put it in my temporary folder, and then and to do that on Apps on Demand, I actually had to go and say upload. Okay, so that way I was able to upload that .c file with the user-defined function to the temporary folder on Apps on Demand, and then I'll say now interpret that. Already did that. I didn't need to do it again. So you see that it hasn't complained, so that's good. And now if I go to materials, fluid, here it says water. It's actually the properties of blood. And for viscosity, I will say instead of constant, now there are some built-in non-Newtonian models, but not the Casson model. So I'll say user-defined, and then it says, which function do you want to use? I want to use Casson viscosity in my user-defined, from my user-defined function file. Then I'll say change create, and now mu is being calculated using that function. So come back here. I think I did change create, close, and then I'll just run my iterations. I already have the solution to the Newtonian one, so I'll just extend it to non-Newtonian. Okay, once it's iterated, I can go back to the workbench folder, and then I can just drag my initial results also to this particular one for my new calculation, and then I'll open CFD post. And I will go to the chart. I have too many lines here, so I'll get rid of some of them. Okay, so here I have, the fully developed profile at the end of the tube, and this is my original one with the Newtonian, and with the Casson, you see I get a flatter profile, which is what you expect. And this is a little bit jagged. To get a smoother curve, I can go back to my original location and increase the number of samples. Let's say actually 101 probably works better than 100. For some reason, and so you get a somewhat smoother profile. And then you can exit out of CFD post and Fluent, and then come back here and say file, save, and then I'll say file, archive. I'll just overwrite that. Let's say yes, and make sure you tick, you select everything, especially imported files. That'll have, that'll load in the UDF. And then once that's done, I need to make sure in apps on demand, I go to temporary files and download that and save it to a network folder.